Hi guys, welcome back. Today I am going to show you the effect of PWM on the motor behavior in two different ways, and I will keep the PWM duty cycle same in both the demonstrations. So this is the first demonstration. Just hear the sound of the motor. So you notice that the speed of the motor started to increase smoothly without any jerk. Now notice this second demonstration. So did you observe any difference between both the demonstration? In the first demonstration, the motor started to increase its speed very smoothly without any jerk. But in the second demo, it got a jerky motion, right? It was not smooth. So this is happening just because of one PWM setting, and I will explain you what is that setting in this video. So let's get started. Now before stepping further, I want to explain you two important things in the circuit. So the first one is that if you observe closely, I am not connecting the motor pins directly to the motor driver. Before that, I am connecting a flyback diode here across the terminals of the motor. So whenever you work with the inductive loads like this motor, relays, solenoids or even electromagnets, the use of flyback diode is generally recommended. Because whenever you turn off the power supply, they try to keep the current flowing across them. And because of that, they create a massive voltage spike, which we generally call it as back EMF. And because of this back EMF, the microcontroller may get reset or even other components like this motor driver may get damaged. So the flyback diode gives that current a safe closed path for properly dissipating. So instead of creating a dangerous voltage spike, the current briefly passes through motor, then through the flyback diode and again through the motor coil. So it creates a kind of loop. So energy then decays safely without any massive voltage spike. Now the second important thing is the common grounding problem. So later in the video I will show you opening the serial plotter. So for that purpose I will need to power this Arduino from the computer itself. But I will power this motor driver from the battery itself, which is this one. So there must be a common ground between the motor driver and the Arduino. So for that purpose I am connecting two jumper wires. This one gray and this black one, which is connected at the middle pin of the motor driver, which is this one. So this is the ground pin. So one wire will be connected to the negative terminal of the battery and other wire will be connected to the ground pin of the Arduino, which is this one. So this black wire is acting as a common ground between the motor driver and the Arduino. So this is the program for demonstration 1 in which we are implementing normal PWM. So on this pin we will send the motor speed, this is the duty cycle, and this rising is a variable to check whether the speed is increasing or decreasing. And the 7 and 8 pins are the direction pins of the motor driver. And in the loop function, this is the logic to check the speed is increasing or decreasing. So if the rising is 2, then we are increasing the speed, and otherwise if the duty is greater than this threshold 255, then the rising will be set to false. After setting it to false, else condition will be true and the speed will start to decrease. And this analogWrite function is used to set the motor speed. And if you remember in the starting of the video, I said that just by changing one PWM setting, the motor behavior gets totally changed, and that setting is the PWM frequency. So by default, the PWM frequency is 490 Hz for 8-bit microcontroller, because Arduino Uno is also 8-bit microcontroller. So this is the default frequency of the PWM. And at this frequency, the motor starts to increase its speed very smoothly. So you will see this kind of graph on your computer screen. You can see the duty cycle and voltage both are increasing, but the frequency is same. So this is the program for second demonstration, and in this program I have changed the frequency from 490 Hz to 5 Hz. But this time I am not using analogWrite function. Instead I am using these hardware registers, which are timer 1 registers, TCTR1A and TCTR1B. But I am not going into the details of these hardware registers, otherwise the video would get too long and you will be bored. So in this setup function I am setting the frequency to 5 Hz, right? And the loop function, these conditions are same as in the previous case. And in this line I am setting the motor speed, which is analogous to the analogWrite function. So you can see the serial plotter is not very much different from the previous case, but we have seen the changing motor behavior in the second demonstration. And you will notice that the motor will start to stop in a jerky motion. So why didn't I use analogWrite function in the second program? Because it has got some limitations, like duty resolution. With the 8-bit microcontroller, you can set only values from 0 to 255. And if we talk about the frequency, you can have only 5 fixed options per timer. And the minimum frequency which you can set is 61 Hz. You can't go lower than that, right? So in the second program, I was setting 5 Hz, which is lower than this. That is why I didn't use analogWrite. And talking about the custom TOP, it is not possible with this analogWrite function because ICR1 register is ignored. But with the direct register programming, you can set custom frequencies and you can have as many frequencies as you want. So if you enjoyed this video and learned something new, then subscribe to my channel for more such video tutorials, and let me know in the comment section whether you are already familiar with this concept or not. And let us meet with a new project in another video, and thanks for watching.